So here we are on quite a warm day, so we've got the air conditioning rumbling in the background. We've got a Harvard 420M, which I have to admit is one of my favourite UK CB radios, and I also like the RVC 230 Rotel, which is of course the same chassis, but this has got the bigger speaker like you get in the Binatone 5-star. So, I'm not sure why that's got damp. Is this radio full of water or something? Anyway, this has come direct from eBay, allegedly in working order, and has been sent to me from the eBay vendor direct here for service, and I'll send it on to the customer. Now we're going to be doing two Harvard 420Ms, and I don't know whether we're going to do it back to back or whether we're going to do them as separate videos. They're the wrong case screws. So we are going to do the testing back to back. I think we'll do them separately. And then, so this is Dave's Harvard 420M. Now by doing it this way round, it means that we've not done somebody else's radio that was in between. So we're actually doing next week's Harvard 420M this week, and I'm going to slot in the customer who's missed out later on in the week, so that he's not disadvantaged. So far so good, it looks nice. It actually still smells of cybernet radio, which is incredible after 40 years. So with the factory original microphone, it's got the Harvard coffin mic. It's come with a power lead. Just check the fuse isn't a piece of something bizarre. So we've still got the HMV Stereo Master 2419 underway. That's the one which had been turned into a trinket cabinet. I think the amplifier's finished, and Mr. Chippy has repaired the fault on it, as well as doing the capacitors, which you'd expect us to do. The trouble with that model is you've got to put it in the cabinet because the transformer is in the cabinet. So you can't test it on the bench, which is frustrating. I suppose we could find out what the transformer was and buy a transformer which is that voltage and rig it up in a box and all that kind of stuff, but I don't think we're getting that many in. I think the 24.9, we're getting more 24.11 and 24.12s than 24.19s. So we will power this up. Just like that. I've got about 20 minutes before lunch. I think we can make a good start on this. So that is Dave's. So connect it up to the test equipment. And extension speaker. We'll switch it on, it comes on channel 19. Switch picture in picture on. Is that in the right position? Gets up. No, I want it there. I like the colour of it there. So with the radio test set in the 3 watt range, we should key up and get more than full scale deflection. we get just full scale deflection, so the radio is doing 3 watts. Let's go over to the 30 watt scale, it's doing 2.9. So what we'll do, we'll use this piece of paper. So TX equals 2.9 watts, deviation, wallow. Deviation equals 2.5 to 2.7, so it's a little bit high, just needs to pop that down. It's probably not balanced right anyway. So, I can't really see the frequency, we've only just put the test set on, but we will look at the frequency. So it's 27,790.94. Now I'm going to adjust that here and now. We'll probably have to adjust it again in half an hour's time. It is within limits. So it's bang on, isn't it now? So I'll make a note that we've set it to that. And we'll see what happens as the test set warms up. So that's as far as transmit goes. Let's look at receive. We'll just need to put 2779125 on the test set. That'll do. We'll go over to the cybernet meter. It's not quite straight, is it? Right. Receive. So that's 1 microvolt. It's 0.3 microvolts, so it's not quite 0.3. It's 0.34. That's excellent. It's 0.34 microvolts for 12 dB cyanide. And just for the record, what does it ever do? 20? It does actually. It does it for 1.1. So it's 1.1 microvolt for 20 dB cyanide. Right. So visual inspection. We've got no capacitors that are popping their aluminium out, because if they get overheated, they start, this heat shrink migrates backwards. So we can't see anything there. The experience is that on this chassis we haven't got any capacitor failures that are happening on their own yet, unlike the Unidens. But of course, if somebody applies higher power than 15 volts, then that is going to happen. But I can't see any signs, and it's working normally, so we don't need to change any capacitors on this occasion. So we'll get on to, I've still got the other multimeter, haven't I? It's in the chapel, the one I like to use. I'm not a lover of auto ranging. I'm not a lover of these prods either. Mr. Chippy's crocodile clip lead. We like red leads for negative. So the negative is that strap there. We need to select, let's put a squelch on, we need to select a different channel, don't we? So let's look at the instructions, because I have a memory like a sieve. Channel 40, and at test point 1, this is receive. Test point 1's resistor 4, and what we should have is 4 volts plus or minus 0.1. I'm going to just change that round and take it off and hope I remember to put it back on, or hope when I put it back on it actually works. So that doesn't need adjusting, but just for the record we'll adjust it. There we go. Put the unit into transmit and make sure it's 4 volts. So it's not quite 4 volts with just the red trimmer. You know, if you come up to a set which is as close as this, it doesn't need doing. This is just for the demonstration, even though I've done it a million times before. So that's the highest it wants to be. Fair enough. So back to receive, 4 volts ish, transmit 3.96. Then we go to channel 1. And needs to be between, on transmit it means it needs to be between 1.8 and 2.5 volts. You know what's happened, don't you? Because these prods are daft, they're over safe. So it needs to be between, as I was saying, between 1.9 and 2.5 volts. So that's bang on. And now we let it go into receive, and it needs to be between 1.9 and 2.5 volts. I just apologise, I said 1.9 to 2.5 on transmit. It's 1.8 to 2.5 on transmit. So we're bang on the money there, that's spot on. It didn't need adjusting, but that's just for the demonstration. So the receive is that on channel 40 for 4 volts, transmit is that for channel 40 on for 4 volts. We'll go back to channel 20 before we tune it all up wrongly. Straight away we're going to transmit. I'll put picture in picture back on, and let's see whether we can get more than 2.9 watts. And I've straight away gone and upset the VCO. Must be that happy shopper soup I'm looking forward to. So back to channel 40. See if I've upset the receive. I have. I don't edit these cock-ups out because this is what happens in reality. Check transmit. That's fine. Go to channel 1. I'll just check receive. And that's within the limits. Good. So write out 1,000 times, I must not adjust the VCO when tuning up the transmitter. I once had to write out 1,000 times, I must not act the fool in class. I hid behind the curtains thinking my best friend had come into the schoolroom. I'd be about 13 at the time, and I jumped out on top of the lad who I thought I was larking about with, but I didn't. I jumped out on top of the teacher who wasn't amused. Can't even remember his name. Oakwood Comprehensive School, Rotherham on Moorgate Road, now demolished and replaced. And I've said a million times before, I was at school with James May, who co-presents Top Gear. Not that I have a television. So there we are. Right. I lent him a magazine in 1976 and he never gave it me back. Everyday Electronics. There was a wah-wah pedal he wanted to make. Okay, So transformers 2, 3 and 4 is there. No improvement there. This is just where the wiring bundle is. No improvement there. Minute improvement there. Of course, the more you transmit, the hotter it gets, and the transmit then drops down. So with the green or the blue trimming tool, see if we can persuade these to fit today. Yeah. I don't remember getting that set. So we need to maximise L4, 8 and 9. So that's 4.4 watts, 4.5 watts, 5.2 watts. Just go through those again. Can be interactive. 5.3 watts, 5.3 watts, 5.3 watts. Now then, it's rotate L4 clockwise for 4.4 watts. So it's tuning down. .4 watts. And now we turn L9 anti-clockwise. They say for 3.8 watts, but we're going to let the customer have 4 watts because that's what they're entitled to in this country. So now what we do is we go to channel 1 and check it's relatively well balanced. I don't really want it to be more than 0.2 out on the between 1 and 40. So it's spot on the 4. It could be, you could say that was 4.02 or something. And on channel 40 it's spot on the 4. So we've got that nicely balanced. Back to channel 20, it's 4. So good, that's what we want. So the meter now reads a bit over, and the meter adjustment is there. It's RV4. We'll turn that now down to read 4. Well, like that. Low power. So it should be 0.4 watts. I've switched to test set to 3 watt scale. So it should read about there. It doesn't work at all. Now these can play up. And there we have 400 milliwatts. And back to 4 watts. When I find the switch, there we are. Okay. Deviation. So it just needs to come down a fraction. But you've got this mic gain one, which should be in its central position. And it isn't in its central position. There's quite a setup procedure to do this properly, but I have found that to set this the way I'm doing, because RV2 is deviation, and RV6 I think is mic gain the way it works. Anyway, it doesn't matter what it is. I set that to central position, and then we work on the deviation control RV2. So we'll just see where we are now with that. It actually looks right. Wallow. No, it's a fraction over. Wallow. Still a fraction over. Wallow. That's it. Say it's about 2.3 to 2.5, so that'll do. So we've done 4 watts and 0.4 watts, so we've done that. We've now got that at 2.3 to 2.5, so that's done. See whether we're still on frequency, because that kind of time's now elapsed when the test set's warmed up. That's fine. Over to receive. So we're going to start with putting the oscilloscope on, turning the bench light off, putting the right camera on there, and putting a 100 microvolt signal on the test set, turning the volume until I get a decent trace, and then adjusting the detector coil there. That was slightly out, so that's good. That's an improvement on clarity and volume. Okay, so we'll go over to the cybernet meter now and see whether we can get any improvement. I'll be surprised if we can. It's already working beyond what the manual says. So put the bench light back on. So as I've said before, if you've been watching these, on the cybernet meter we want to be not saturating the receiver, so we're turning that down to about 4 dB. And as you improve the receiver, you're increasing the you then increase the signal generator, sorry, you decrease the signal generator, so it is a just usable signal as we have right now. So we'll start with that coil there under the wiring. It was already spot on. With a bigger signal with these IF1s, put an even bigger signal on. Quite an improvement on that one. And is there the hidden one under the wiring there? There is. Doesn't need adjusting. So that was slightly out, and that was about it. So let's see what the sensitivity is now on the cybernet meter. Have we got any improvement whatsoever? Well, it was 0.34. It's now 0.32. You know, you could come and do this another day and it would be different again. And then for 20 dB, we might have improved that actually. Let's hope we haven't unimproved it. Yeah, we have. That's because of that coil, and it could be because of the detector as well. So it's now yeah, that's right. It's 0. Actually, I can go down a scale. It's 0.95 microvolts. There we go. So now we can turn the volume down a little bit, switch the switch the cyanide meter off. I'll put this onto the attenuator controls, and we want 100 microvolts, which is there, and that should give us 9 on the meter. It gives us 7.5, 8. So to adjust the meter, we just need to turn that preset, and that should now read 9. I did check the RF gain was up, and it is. And now we just do the squelch. So with the squelch on full, I would like this radio to have the squelch opening when it's 100 microvolts on full, and it doesn't. It's 300 microvolts. So we'll just adjust the preset squelch till it comes in. And it comes in there. So that's realigned that. Now then, at the sensitive end, I'm parking the signal generator at 0.3 microvolts and switching it to standby. The red light indicates standby. We're going to turn the squelch control on the radio to threshold and see when that comes in. So switch the signal generator back on. Well, that's pretty loud. It's coming in at 1.3, leaving at 1.1. I'll just see whether I can set it a bit more accurately. You shouldn't have to do this, but see whether that's a bit better. They aren't the best squelch in the world on the cybernet board. Yeah, it's coming. So we can set it really, really carefully, at which point it comes in at 0.4 of a microvolt and leaves at 0.35. So it will do the sensitive end, so it will do scratchy corner. So we'll put the lid on it. Why it's a bit short actually. It was a bit of a swine to get off. So it's going to be a bit of a swine to put it back on. Wrong way round. Right way round. So apart from the fact it wasn't working on low power, that's now working great. Talking of great, we've got a great set to do after these two Harvards. I would suspect somebody's put new screws in this to get rid of the nasty rusty ones which could have been in before, because they're not the normal. You know, there's Phillips and there's Posi Drive, and Mr. Chip will tell you which is which, but this is the other. We've got a transistor radio to do. I bought it from the United States. See if we can get it to work. And it's going to make you all smile. I'll try and slot that in at the weekend. You thought, what's he wasted his money on now? So there we are. Beautifully working. And, you know, the vendor said it was working, and apart from the fact it was doing 2.9 watts, it was working. But that's fine. It was working. I'm going to plug the test gear back in instead of the Antron 99 roof aerial. There we go. So, is anybody on? 1 Nana Roger. Nineteen a Roger. 1 Nana Roger. Help to be key the mic. No. Right, we'll talk to Mr. Chippy later on that. Thanks for watching the Harvard 420M.